So if you're working on a blank sheet of paper, which some of you are, honestly, the most important things on this paper are these sentences right here. So I would copy down these sentences because that's what you'll use to get the homework done. So starting at the top, it says a blank or blank is a statement that is accepted as true. That is a postulate. A postulate is kind of like a definition, but more for a concept. So a postulate, the other thing it could be called is an axiom, but most of the time we see it as postulate. It's a statement that is accepted as true without proof. Basic ideas about points, lines, and planes are postulates. Okay, the first one, and again, we've already touched on this concept, but through any 2 points, there is exactly one line that goes through them. So over here, it has a little example. There's 2 points, so that means one line can be drawn through those 2 points. On the paper, it's pretty obvious that you can draw a point or a line through those 2 points, but remember, they don't really have to be on a flat surface. You can have a point here on the board and then a point here on my desk, and through any 2 points, you can draw one line. Whether that line is drawn or not, you can draw one line. Postulate 2.2, a line contains at least 2 points. So if you have 2 points here, maybe point A and B. So a line contains at least 2 points. Next, through any 3 non-collinear points, so looking at the vocabulary here, 3 non-collinear points would be 3 points that aren't in a straight line. There is exactly one plane that contains them. So here it shows 3 non-collinear points, and we can draw a plane that contains them. Let's call this plane M. Again, in this case, it's pretty obvious that those 3 points fall on a plane, but sometimes it's not obvious. If I had a point on the board, a point on the desk, and then a point on, let's say, the floor over here, you could draw a plane that goes through those 3 points. So any 3 points, you can draw a plane through, one plane. A plane contains at least 3 non-collinear points. So here is a picture, 3 non-collinear points are on that plane, at least 3. And next, if 2 points lie on a plane, then the entire line containing those points lies on that plane. And there's a typo here. If 2 points lie on a plane, then the entire line containing those points lies on that plane. How does that look? Well, if we had point L and then point M, we could draw a line through those points. And since L and M are on the plane, then that line is also on the plane. Next, 2 lines intersect at exactly 1 point. So, line here and a line here, they intersect at a point. Also, you may notice that each of these are labeled postulate 2.6, postulate 2.7. Those numbers aren't important. The concept is the thing that's the most important. The numbers refer to the numbers in the, based on the textbook. This would be chapter 2, 2.7. I don't know. So don't focus on the number. Thank you. Appreciate it. Emily, you probably need one of these, yeah? If I give you one of these, you have to do the work, right? Thank you. Okay. Postulate 2.7, 2 planes intersect at exactly 1 line. So here we can see the two planes intersecting. Remember, planes go on forever and ever. In this visual here, they show it as a rectangle, but the plane would actually go on forever, so they intersect at a line. When we're done? Okay, thanks. It'll like 5 minutes. Okay. Postulate 2.8, ruler postulate. All it says is every point on a line can be compared with a real number. It means that you can measure these line segments with real numbers, like on a ruler. Next, the next word is theorem. I know you've heard this word in science. It means something similar in math as well. A theorem is a statement or conjecture that has been proven to be true. It can be used as a reason to justify statements in proofs. Okay. First theorem for the chapter, and there'll be many of these. Once I explain them, a lot of times they're just common sense. It just makes sense. For example, midpoint theorem says if M is the midpoint of AB, then AM is congruent to MB. AM is congruent to MB. So if M is the midpoint, then AM is congruent to MB. Means this side is the same length as this side. And also we can use definition of midpoint. If M is the midpoint of segment AB, then AM is the same length as MB. So when we see it with the equal sign, it's referring specifically to length. So the length of one part is the same as the length of the other. Why do they separate that? Well, when we say things are congruent, when we're talking about segments, yeah, we're talking about they are the same length. But let's say that we were saying that two triangles were congruent, we'd be talking about more than just length. So that's why we have these two separate statements. Okay, now we're going to look at questions like you'll see on the homework or how they might incorporate these ideas in questions. For the first set of questions, it says, determine whether each state is always, sometimes, or never true. First one, it says line R, so I'm going to draw line R, contains only point P. Is that always, sometimes, or never true? Well, it says only 1 point, and we were told that lines have 2 points. So this is never. A line contains at least 2 points. Number 2, through 2 points, there is exactly one line. Through 2 points, there is exactly one line. That is always true. That's literally almost the definition. So, through any 2 points, there's exactly one line. I'm going to try to make this short. Through 2 points, exactly one line. Next, there's exactly one plane that contains non-collinear points A, B, and C. So 3 non-collinear points, yes, exactly one plane, that is always. And the reason is through any 3 non-collinear points, there's exactly one plane. Any 3 non-C points, I'm abbreviating, one plane. So what that says is through any 3 non-collinear points, there's one plane. Number 4, if points M, N, and P lie on plane Z, then they are collinear. Well, if they lie on a plane, they could be like this. They could be collinear, but not necessarily. So this one's sometimes. So if you have 3 points in a plane, they could lie on the same line, or they might be non-collinear, so that's sometimes. And then number 5, the intersection of 2 planes can be a point. No, the intersection of 2 planes is a line, so this is never. And the last 3 questions are a little bit different, kind of a similar idea, but we're referring to a picture over here. So number 6, it says exactly one plane contains points F, B, and E. So F, B, and E. And you're stating whether it's true and explaining why. Well, F, B, and E, 3 non-collinear points. Yes, you can draw one plane through it, even though it doesn't show it. So this is true. Through any 3 points, there is one plane. And abbreviating. Any 3 points, one plane. And next one, it says line BE lies on plane Q. Okay, here's point B, here's point E. There is no line drawn through there, but it doesn't mean there couldn't be a line drawn through there. So any 2 points, there is a line that lies on the same plane. That was actually one of our postulates over here. If 2 points lie on a plane, then the entire line containing those points lies on the plane. So this is true. And how do I say it briefly? 2 points on a plane, then the line is on plane. Next, number 8. The intersection of FG and AC is point B. FG and AC is point B. That is true. 2 lines intersect at a point. And some of these will actually repeat on your homework, just FYI. And then number 9, it says planes ABF and CDG intersect at line CD. And that is true. It intersects at a line. So this is true. 2 planes intersect at a line. And that's it for today. So we still have 25 minutes left in class. What I need you to do is to get a laptop, hop on and do your homework on Schoology on the laptop. Then once you're done with that, hop on to Khan Academy to work on Khan Academy.